Hi everyone, in this lesson we are going to be looking at other mechanisms for regulating glucose concentration in the blood. So we're going to be looking at two other hormones, not insulin and glucagon, but cortisol and adrenaline. You may have heard of these hormones before, and in this lesson we're going to look at how they operate in the body. The learning objectives for this topic are pretty similar. We're going to relate this back to negative feedback loops. So those key words that you need to understand still apply. And specifically, you need to be able to explain how cortisol and adrenaline regulate blood glucose concentrations. There's a lot of key words in this list. Some of these you have seen before, so hopefully that shouldn't put you off. Words like glycogenolysis and pituitary gland you have seen before. Other ones may be familiar, but we will talk about these throughout the lesson. Just to get you started, what I would like you to do is to watch this short 2-minute video on how adrenaline works. Once you've done that, come back to the lesson and we'll continue on. Okay, so before we talk about adrenaline and cortisol, we need to address the endocrine organ that these come from, and that is the adrenal gland. You can see from this diagram that you have two adrenal glands situated on top of the kidneys. And if we cut that in half down the middle, we can see that there's this outer cortex area and an inner medulla. So the way I used to remember this was the cortex, or the adrenal cortex, is the crust, and the adrenal medulla is the middle, just using that word association to help. So these hormones that we have been referring to at the start, adrenaline and cortisol, come from the adrenal glands. These also help to regulate blood glucose concentration. However, they do it under different circumstances. We talked about adrenaline, and we will go on to refer to mostly just adrenaline, but then the adrenal gland also secretes another hormone called noradrenaline that we tend to associate with adrenaline. All right, let's focus on the outside of the adrenal gland. That is the cortex. The adrenal cortex secretes cortisol. And cortisol is a hormone that responds to longer periods of stress. So, for example, if you've been at home for a long period of time and you can't leave the house, that may lead to some feelings of stress. Or if you have an exam in a month's time, that could lead to low levels of stress, and in those circumstances you may secrete more cortisol from the cortex of the adrenal gland. What cortisol does is it stimulates the liver to start breaking down glycogen into glucose. So the function of cortisol is to raise blood glucose levels. If you don't have any glucose in your body, your cortisol hormone will then focus on breaking down protein into amino acids. Amino acids, you'll remember, are the smallest constituent that proteins are made of. Once cortisol has that amino acid, it will then convert it into glucose. So it's making new glucose molecules from amino acids, and this is a new terminology for you. Making new glucose is gluconeogenesis. So gluco for glucose, neo, the word neo means new, and genesis we've met before, that means to create. So we are creating new glucose. If we go to the inside of the adrenal gland, we're at the adrenal medulla. We have tissue where adrenaline and noradrenaline are released from. Adrenaline, mostly, we're going to focus on that, will stimulate glycogenolysis. So remember, that's glycogen splitting. So it's a way to really quickly release glucose into the bloodstream by breaking down glycogen into glucose, and that occurs in the liver. Adrenaline is a short-term, fast-acting stress hormone. We tend to respond to fight or flight situations with adrenaline. So that means that we have this really quick, rapid release of glucose. What I'd like you to do is just to stop here and watch this short video on adrenaline before you move on. Please make sure you're logged into Twig to do that. Okay guys, now a little summary of what we've learned so far. We know that we have the adrenal glands, which are endocrine organs, and they are located on top of the kidneys. The outside crust or outer portion of the adrenal gland is called the cortex. And the cortex releases a hormone called cortisol. Cortisol will respond to longer-term stress by helping the body to regulate its blood glucose concentrations. It does that through making new glucose. So this is where if we don't have enough carbohydrate in our body, we will look to alternative sources such as proteins, and we will break them down to amino acids, and those amino acids will be converted into glucose, which can be used. So that is gluconeogenesis. If we do have carbohydrate in our body, we will break that storage carbohydrate down, glycogen, we'll break that down into glucose through the process of glycogenolysis. The inner portion of the adrenal gland is called the adrenal medulla, and the adrenal medulla releases the hormones adrenaline and noradrenaline. Noradrenaline and adrenaline are associated with short-term stress responses. So that's your fight or flight response. The adrenaline hormone will provide the body with a rapid source of glucose through very, very fast-acting glycogenolysis. All right, so now we're going to look at the negative feedback mechanism of how the hypothalamus and the pituitary gland control the release of cortisol at the adrenal glands. So just to recap, we know that hormones are chemical messengers, and these messages are not released until they are given the go-ahead to do so. So what we're talking about here is these adrenal glands are endocrine glands, and they will not release cortisol unless they get a signal here telling them that they can do that. So we're going to be looking at how this signaling mechanism works. First of all, just to recap, within the central nervous system, we have the hypothalamus up here and the pituitary gland down here. The hypothalamus and the pituitary gland will release hormone messenger chemicals that will stimulate other areas of the endocrine system. In the case of cortisol, the hypothalamus up here will send a message to the pituitary gland, and that message is carried out through this chemical called CRH, and it's basically a releasing hormone. So it's telling the pituitary gland, yes, you can go ahead and send a signal to the adrenal glands. That's what starts everything off. So here, this chemical, CRH, found in the hypothalamus, sends a message to the pituitary gland, which releases a chemical called adrenocorticotropic hormone. So the pituitary gland sends messages, this ACTH, to the adrenal cortex, telling it to release more cortisol. So ACTH from the pituitary gland stimulates the adrenal cortex, which will then release cortisol. Showing you that in a little graphic here. This is a summary of what's happening here. So the hypothalamus secretes CRH and sends that to the pituitary gland, right here. The pituitary gland secretes ACTH, which stands for adrenocorticotropic hormone. that will respond by sending a message in the bloodstream and targeting the adrenal cortex. The adrenal cortex is then stimulated to secrete cortisol. Now, as we know, this all happens in a negative feedback loop. So, if at any point we have too much cortisol in the body, our negative feedback will start to activate, and we will shut down either production of CRH in the hypothalamus, or we will shut down production of ACTH in the pituitary gland. And the overall effects of that are less cortisol is secreted into the bloodstream. Now, just a recap on how homeostasis and negative feedback works. Remember, it works both ways, so you can't have levels that are too low or levels that are too high. We are aiming to be in balance or at the set point. So let's start at the lower end. So our stimulus is we have low levels of cortisol in the bloodstream. Receptors in the hypothalamus will detect that change, that decrease, and they will be stimulated to secrete CRH. That will then travel to the modulator, which is the pituitary gland, and the pituitary gland will secrete ACTH. This will then travel to the adrenal cortex, which will then be stimulated to secrete more cortisol. And as a result of that, the feedback response is we then have an increase in cortisol levels, which will allow the cortisol levels to rise to normal or our set point again. On the other side, if our cortisol levels if we start down here, if our cortisol levels in the blood start to increase, we have the opposite. So the hypothalamus will detect that change. We will have less CRH being secreted. We will also have less ACTH being secreted. And as a result, less cortisol is released from the adrenal cortex, and our cortisol levels will start to reduce back to normal or the set point. All right, so now that we have covered cortisol and adrenaline and how cortisol works in a negative feedback loop, I'd like you to please to complete pages 25 to 27 of your class booklet. Remember, you can self-assess by using the answers in your OneNote, and I'd like you to complete the MyEd quiz online. Thanks for watching.